The equations of motion and the laws of motion we discussed so far describe only the motion of point particles. Now, these balls can be approximated as point particles. The motion of these are simple parts, and so the equations and the laws of motion can be applied to these particles. But when it comes to objects like this, extended objects, if you allow these extended objects to move, it will not be as simple as the motion of these pointed objects. Or if you want to allow this meter rule to move, if you look at the way the meter rule moves, or this object moves, it's a complicated motion. Look at that. Different parts of the object have different motion. Is that right? And therefore, in order to apply the laws of motion or the equations of motion for objects like this, which we call extended objects, we define a term called the center of mass. In other words, when you want to describe the motion of this object, rather than looking at the complicated motion of the whole object, we can look at the motion of one point on this object where the whole mass of this object may be assumed to be concentrated. Now that point is called the center of mass of the object. Now I have a fair idea where the center of mass of this object will be. Tell me, is the center of mass at the center of this rod? You can see there is a ball at the end of this rod. Means the mass of this whole thing may be assumed to be concentrated at a point close to that ball. Now, how do I detect the center of mass? If I have a meter rule, I can detect the center of mass by actually balancing, trying to find the balance point. Look at that. The meter rule is actually balancing at this point, which means the whole mass of this meter rule may be considered to be concentrated at this point. And this point, therefore, is called the center of mass of this meter rule. Well, the weight of the object will be acting vertically through that point. You see that? And I am supporting that weight. That means this object stays at equilibrium. If I try to balance it at any other point, what happens? The meter rule falls off with a complicated motion. Now look at the way this object, I'm going to try and balance this at its center of mass. Let me see if I can find the center of mass. There I have found the center of mass. Now if I drop it from the center of mass, its motion will be simple. It simply drops like a point object. You see, it simply drops like a point object. Whereas if I want to drop it, say if I am going to support it here and I drop it, look at the way it moves. It has a complicated motion. And if I want to move it from a point on the other side, again it has a complicated motion. So the center of mass, when you want to consider the motion of an extended object, it is the motion of the center of mass that we consider. Therefore, to locate the center of mass is an important skill, and we will be talking about how to locate the center of mass of a system of objects if the system of objects are distributed at different locations in space. Now, if I have two cars, for example, now if I place two cars on this track, I have two cars here, and you can see the two cars moving. The motion of the two cars can be studied by locating the center of mass of the two objects and then studying the center of mass of the motion of the center of mass. We will talk about all these things in this class. All right. These animations show the motion of the center of mass when an object is projected at different points. If you notice the first diagram, the object is projected vertically at its center of mass. And you notice it is moving as though it is a point object. Now, on the diagram here, it is projected at a point on the right of the center of mass, and you can see the object tumbles as it climbs. But the motion of the center of mass has not changed. The motion of the center of mass on the left diagram and the motion of the center of mass in the second diagram are exactly the same, although the motion looks complicated in the second case. Similarly, the third case, the object is projected from a point to the right of the center of mass. Again, it tumbles the other way, but again, the motion of the center of mass remains exactly the same. The motion of the center of mass can be approximated as the motion of a point particle. Let me also show you when these are projected. We got three diagrams here. The top diagram shows a gun projecting this object at the center of mass. And you can see its motion is very simple, just like you project a ball. And in the second diagram, the projection is done above the center of mass, and you can see how it tumbles. But look at the path taken by the center of mass. The center of mass falls as though it is a point particle. In the diagram below, the projection is done below the center of mass. Again, the object keeps tumbling, but the center of mass follows the path followed by the first case. In other words, the path taken by the center of mass is as though the center of mass is a point particle. Okay, let's now look at how to locate the center of mass of various systems of objects. We will now look at the positions of two cars and how to determine the center of mass of the two cars. Well, a car of mass m1 is at position x1. Well, let's bring the car. This is the car of mass m1 at position x1. And another car of mass m2 is at position x2. We have two objects. An object of mass m1 placed at x equal to x1 on the x-axis. An object of mass m2 placed at x equal to x2 on the x-axis. The center of mass of these cars will be somewhere in between. It will be closer to the bigger car than to the smaller car. In other words, center of mass is a point where the two masses can be assumed to be concentrated. So the center of mass of these two cars is at x center of mass, somewhere here. Now, so that the combined mass of these cars can be assumed to be placed at that point. That means the motion of these two cars can now be studied as the motion of their center of mass. The motion of two objects can be summarized by considering the motion of their center of mass. The motion of the center of mass can be approximated to be the motion of a point particle. Then we can apply the equations of motion and the laws of motion we discussed so far. The x center of mass can be measured. I want you to take note of this equation. Now, what is x center of mass? Where is the center of mass along the x-axis? X center of mass can be written as x center of mass equal to m1 x1 plus m2 x2 divided by m1 plus m2. In other words, the position of the center of mass of these two objects is determined by the masses of the two objects and the positions of the two objects. The position of the center of mass, called x center of mass, is m1 x1 plus m2 x2 divided by m1 plus m2. It's a very simple equation to remember. Now, if there are n objects on the x-axis, not necessarily two, there are many objects on the x-axis, then we can extrapolate that equation. m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 divided by m1 plus m2 plus m3 plus m4. And we can summarize it like this. X center of mass equal to summation I equal to 1 to n mi.xi. I hope you understand these notations. When I equal to 1, mi.xi will be m1 x1. When I equal to 2, it will be m2 x2, and so on. We can do it for n number of objects. In other words, summation I equal to 1 to n mi.xi means m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 plus all the way to mn xn to the nth particle, and divide that by what does this uppercase M stands for? Is m1 plus m2 plus m3 plus m4 all the way to mn. So if there are n objects on the x-axis, the position of their center of mass will be given by this equation. X center of mass equal to summation I equal to 1 to n mi.xi over the sum of the masses. Now, similarly, if you have this n objects on the y-axis, then their center of mass will be somewhere along the y-axis, and we can represent that by y center of mass. Can you write a similar equation for that? It will be y center of mass equal to summation I equal to 1 to n mi.yi over summation I equal to 1 to n mi. Well, this is what we call m1 plus m2 plus m3 plus m4, or which is the same as the uppercase M. So, if you remember these two simple equations, you can find the position of the center of mass along the x-axis and the position of the center of mass along the y-axis. Now, very often, objects will be scattered in the xy plane. That means the center of mass will then have an x position and a y position. The x position of the center of mass will be obtained using this equation. The y position of the center of mass will be obtained using the lower equation. All right, let's see how we can use it. Let's do this problem. Find the center of mass of a system composed of 3 spherical objects with masses 3 kilogram, 2 kilogram, and 4 kilogram, and their centers located at negative 6 meter 0, 1 meter 0, and 3 meter 0. If you look at the coordinates of these 3 locations, the y coordinate of each is 0, it means they are points along the x-axis. Alright, let's place these objects. Let's place the first object. Where is the 3 kilogram object? The 3 kilogram object is at negative 6 meter 0 over here. M1 equal to 3 kilogram, x1 equal to negative 6 meter. So this is our M1, that is the 3 kilogram. Where is the 2 kilogram? M2 equal to 2 kilogram, x2 is at x equal to 1 meter over here. This is the 2 kilogram. And where is the third mass? The 4 kilogram. M3 equal to 4 kilogram, x3 equal to 3 meter. It's here. That is our 4 kilogram. We got 3 different objects on the x-axis. How do we figure out the center of mass? Well, the x center of mass, the center of mass of these 3 objects will be somewhere on the x-axis given by x center of mass, and there are 3 objects. So it will be m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Let's use all the values. m1 x1 3 times negative 6 plus m2 x2 2 times 1 plus m3 x3 4 times 3 divided by m1 plus m2 plus m3, and that gives you negative 4 over 9. The position of the center of mass of these 3 objects is at negative 4 over 9, somewhere here. Of course, the y center of mass is 0 because all these objects are placed on the x-axis. So, the center of mass is at this point, negative 4 over 9, 0. And where is that point? It is right here. This is the x center of mass, which is negative 4 over 9, 0. Okay, let's do another one. Find the center of mass of a system composed of 3 spherical objects with masses 3 kilogram, 2 kilogram and 4 kilogram, the same 3 objects we used last time, but their centers are now located at 0, 5 meter, 0, 0 and 0, negative 4 meter. You can see all the x values are 0. That means these points are along the y-axis. Let's locate them. M1 is 3 kilogram, Y1 is 5 meter. That means your M1, the 3 kilogram is over here. M2 is 2 kilogram, Y2 equal to 0. Our 2 kilogram object is at the origin. Alright. M3 equal to 4 kilogram, Y3 equal to negative 4. Where is M3? M3 will be over here. That is the 4 kilogram. We now need to find the position of the center of mass. The position of the center of mass of these objects will be a point somewhere on the y-axis. What is the equation? Y center of mass equal to M1 Y1 plus M2 Y2 plus M3 Y3 over M1 plus M2 plus M3. All we need to do is replace these by their values. So M1 Y1 is 3 times 5 plus M2 Y2 is 2 times 0 plus M3 Y3 is 4 times negative 4 over M1 plus M2 plus M4, and that is negative 1 over 9 meter. Y center of mass, the position of the center of mass of the y center of mass is -1/9 meter. And what is the x center of mass in this case? Because all of them are along the y-axis, the x center of mass will be 0. And therefore, the location of the center of mass is at 0, -1/9. Where is that? It is actually very close to the origin where I'm pointing. There, that is y center of mass is 0, -1/9. Okay. We have now 3 balls A, B and C of masses 3 kilogram, 2 kilogram and 1 kilogram are placed as shown in the figure. So this is your A, this is the 3 kilogram, this is the B, which is your 2 kilogram, and C is our 1 kilogram. I hope you can see that C03. I think it is cut off. Okay. C equal to 1 kilogram is at 0.3. Is that right? Is this right as 0.3? Well, that's not right. This should be 3,0. Is that right? I must label this point as x equal to 3, y equal to 0. So please make that correction. It is not 0.3 but 3,0. Okay. We will now need to find the center of mass of these 3 objects. Now you notice that each object has an x position and a y position. Object A has an x position equal to 2, y position also equal to 2. Object B has an x position equal to 1, y position also equal to 1. Object C has an x position equal to 3 and the y position equal to 0. I hope you made that correction. This is 3,0. That means there will be an x center of mass. The x center of mass will have an x. The center of mass of these 3 objects will have an x value and a y value. And we can find them separately by using the x center of mass formula and the y center of mass formula. Alright, let's do that. M1 equal to 3 kilogram, x1 equal to 2 meter, you see that? x1 equal to 2 meter and y1 also equal to 2 meter. x1 equal to 2 meter, y1 equal to 2 meter. M2 equal to 2 kilogram at B, x1 equal to 1 meter, x2 equal to 1 meter, y2 also equal to 1 meter. How about M3? M3 is 1 kilogram and x3 equal to 3 meter and y3 equal to 0. Now once you have x1, x2, x3 and m1, m2, m3, we can find the position of the x center of mass. And then you have y1, y2, y3 and m1, m2, m3. We can find the position of the y center of mass. Let's do that. X center of mass is m1, x1 plus m2, x2 plus m3, x3 over m1 plus m2 plus m3. And that is 3 times 2, m1, x1, 3 times 2 plus m2, x2, 2 times 1 plus m3, x3, 1 times 3 divided by 3 plus 2 plus 1. And that's equal to 11 over 6 meter. The x center of mass is 11 over 6 meter. Okay, how about the y center of mass? Y center of mass is m1, y1 plus m2, y2 plus m3, y3 over m1 plus m2 plus m3. And now use these values. m1, y1, m1 y1 is 3 times 2 plus m2 y2 is 2 times 1 plus m3 y3 is 1 kilogram times 0 meter divided by m1 plus m2 plus m3, and that is 4 over 3 meter. Therefore, what is the location of the center of mass? The center of mass is located, which has an x position 11 over 6, y position 4 over 3. Now, where is 11 over 6? 11 over 6 is very close to 2. So the x position 11 over 6, y position 4 over 3. So this is the position of the center of mass. It will be 11 over 6, 4 over 3. Okay, let's move on. We will now talk about the motion of center of mass. You see, why did we talk about the center of mass? To talk about the motion of the center of mass. If two objects are moving, it means their center of mass is also moving. Is that right? Yes. If two or three objects are moving, and if they have a center of mass, then the center of mass is also moving. And what will be the velocity of the center of mass? The motion of several objects together can be studied by the motion of their center of mass. If forces F1, F2, F3 act on objects A, B, and C respectively, then the center of mass of the system will move obeying the laws of motion. What is the law of motion? F net equal to ma. Now tell me, if a system is made up of three objects A, B, and C, a force F1 is acting on A force F2 is acting on B, a force F3 is acting on C. What is the force acting on the center of mass of these three objects? Well, remember, the center of mass represents all the objects in the system. That means the force now acting at the center of mass will be F1 plus F2 plus F3, the sum of all the forces. So the net force on the center of mass is the sum of all the forces. So you will have F1 plus F2 plus F3 equal to, what is the total mass? What is the mass of the center of mass? You see, center of mass is a point where the masses M1, M2, M3 are assumed to be concentrated. So the mass of the center of mass is the sum of the masses. So we say the sum of the forces equal to the sum of the masses times the acceleration of the center of mass. So this equation represents the acceleration of the center of mass. Or we can write like this: A center of mass equal to, this is summation of all the forces, which we call F net. F net is the sum of all the forces at the center of mass. And M1 plus M2 plus M3 is summation of M. So A center of mass equal to the net force divided by sum of all the forces. A center of mass, acceleration of the center of mass equal to the net force at the center of mass divided by the total mass, which is the mass assumed to be concentrated at the center of mass. Now, if V1, V2 and V3 respectively are the velocities of their center of mass, velocities of the three objects, then the velocity of their center of mass is related to these velocities. Now look at the equation for the velocity of the center of mass. velocity of the center of mass is m1 v1 plus m2 v2 plus m3 v3 all over m1 plus m2 plus m3. Now, this is an important equation that gives you the velocity of the center of mass. If I have three objects of masses m1, m2, m3, are moving with velocities v1, v2, v3 respectively, then the velocity of their center of mass will be given by v center of mass equal to m1 v1 plus m2 v2 plus m3 v3 all over m1 plus m2 plus m3. Okay, let's do a small problem. A force of 9 Newton I is applied on object A of mass 3 kg. A force 2 Newton I minus 3 Newton J is applied on object B of mass 2 kg, and a force negative 3 Newton I plus 4 Newton J is applied on object C of mass 1 kg. Find the acceleration of their center of mass. Well, we have the equation. What is the equation for the acceleration of the center of mass? Acceleration of the center of mass is F net, the net force, the sum of all the forces, divided by the sum of all the masses. Alright, let's do that. F1 plus F2 plus F3. F1 is 9 Newton I. F2 is 2 Newton I minus 3 Newton J. F3 is negative 3 Newton I plus 4 Newton J. When you add them, we add the x components. That will be 9 Newton I plus 2 Newton I minus 3 Newton I. That will be 8 Newton I, adding the x forces. Similarly, add the y forces. Negative 3 Newton J plus 4 Newton J is 1 Newton J. So the net force is 8 Newton I plus 1 Newton J. Therefore, acceleration of the center of mass is the net force divided by the sum of the masses. That is 8 Newton I plus 1 Newton J divided by 6 kg. In other words, this acceleration has an x component and a y component. What is the acceleration along the x direction? It is 4/3 meter per second squared I. H over 6I is 4/3 meter per second squared I plus 1 over 6 meter per second squared J. So, the acceleration of these three objects is given by this quantity, which consists of an x component and a y component. What is the magnitude of this acceleration? The magnitude of the acceleration is square root of x squared plus y squared. See, we do this so often, it becomes part of your vocabulary now. Is that right? If this is the acceleration vector, the magnitude of that will be square root of 4/3 squared plus 1/6 squared, and that is 1.34 meter per second squared is the magnitude of that acceleration. Well, what is the angle of that acceleration? Angle theta is given by theta equal to tan inverse of y over x. Theta is tan inverse of 1/6 divided by 4/3. Now try this on your own on your calculator. And that will be 7.1 degrees. So under the action of these forces, the acceleration of the center of mass will be 1.34 meter per second squared at an angle 7.1 degrees. Okay, so we are applying now the laws of motion to the motion of the center of mass of a system of objects. All right? Let's now do a small problem. A 1500 kilogram car is moving westward with a speed of 20 meters per second, and a 300 kilogram truck is traveling east with a speed of 16 meters per second. Find the velocity of the center of mass of the system. Well, you should understand that if a speed is given to be westward, if you would take that as positive, then a speed in the east direction will be negative. So here, instead of giving you velocity, I give you speed and direction. So you must understand, in our calculations, we use velocity. So a speed of 20 meters per second westward, if that is positive, then the eastward speed will be negative. But it is conventional for us to take the east as the positive x, west as the negative x. Is that right? Yes, there you have the car going west. A car of 1500 kilogram has a velocity v1 equal to negative 20 meters per second. Look at that. I used the westward direction as negative. So m1 is 1500 kilogram. v1 is negative 20 meters per second. And now I have another car, a truck, that goes east. Its mass m2 is 3000 kilogram. Its velocity v2 is 16 meters per second. Where is its center of mass? Its center of mass will be closer to the truck than to the car. It will be somewhere here. And we need to find the velocity of that center of mass. Alright? V center of mass equal to m1 v1 plus m2 v2 divided by m1 plus m2. Very simple equation. Once you identify all the quantities, simply use them in the equation. m1 v1 1500 times 20I plus m2 v2 3000 kilogram times 16I divided by m1 plus m2. And that will be 4 meters per second I. The center of mass of these two vehicles will be moving at 4 meters per second in the east direction. Okay. That's the center of mass. It is moving east at 4 meters per second. Alright, let's do another problem. Two 3 kilogram masses have velocities v1 equal to 2 meters per second I plus 3 meters per second j, and v2 equal to 4 meters per second I minus 6 meters per second j. Find the velocity of the center of mass of the system. Well, in this case, each object has velocities in the x and y direction. It's a two-dimensional motion. That means the center of mass velocity will also have an x component and a y component. We calculate them separately. Alright, how do we do that? We will obtain the x and y components of the velocity of the center of mass separately. Now, m1 equal to 3 kilogram v1x. The velocity of the first object in the x direction is 2 meters per second. Is that right? v1 equal to 2 meters per second I. That 2 meters per second is the velocity in the x direction. So that is your v1x. And the 3 meter per second j is the velocity in the y direction. v1y equal to 3 meter per second. I hope you understood how I identified that. Similarly, we have m2 equal to 3 kilogram and v2x. v2x is 4 meter per second. And v2y is negative 6 meter per second. Let's now calculate the velocity of the center of mass in the x direction. Now look at the way I named it. Vx center of mass. In other words, the velocity of the center of mass in the x direction is m1 v1x plus m2 v2x over m1 plus m2, and that is m1 v1x 3 times 2 plus m2 v2x 3 times 4 divided by m1 plus m2. m1 is 3 kilogram, m2 also is 3 kilogram, and that is 3 meter per second I. That is the velocity of the center of mass in the x direction. Similarly, we find the velocity of the center of mass in the y direction. Vy center of mass equal to m1 v1y plus m2 v2y over m1 plus m2. That is m1 v1y is 3 times 3 plus m2 v2y 3 times negative 6 divided by m1 plus m2, and that will be negative 3 over 2 meter per second j. So the velocity of the center of mass now has an x component and a y component. Putting it all together, we get velocity of the center of mass is 3 meter per second I minus 3 over 2 meter per second j. You can leave it like this, or you know how to write that in the magnitude angle form. Try that on your own. Write this in the magnitude angle form. Okay, let's now do another simple problem. 3 balls A, B and C of masses 3 kilogram, 1 kilogram and 1 kilogram respectively are connected by massless rods. It simply means that ignore the mass of the connecting rods, and are located as shown in the figure here. A is located at x equal to 2, y equal to 2. B is located at x equal to 1, y equal to 1. And C is located at x equal to 3, y equal to 0. What are we supposed to find? Find the coordinates of their center of mass. And B, if a force F equal to 12 Newton I is applied to the 3 kilogram ball, what is the acceleration of their center of mass? Well, A has a mass m1 equal to 3 kilogram and is located at 2, x equal to 2, y equal to 2. m2 equal to 1 kilogram is located at x equal to 1, y equal to 1. m3 equal to 1 kilogram is located at x equal to 3, y equal to 0. The x center of mass, the center of mass of these will be somewhere here. It has an x position and a y position. The x position of the center of mass is m1 x1 plus m2 x2 plus m3 x3 over m1 plus m2 plus m3. That will be m1 x1 is 3 times 2 plus m2 x2 is 1 times 1 plus m3 x3 is 1 times 3 divided by m1 plus m2 plus m3 is 3 plus 1 plus 1. Now do that on your own and see whether I got the right answer. That is x center of mass equal to 2. How about the y center of mass? Y center of mass is m1 y1 plus m2 y2 plus m3 y3 over m1 plus m2 plus m3. m1 y1 is 3 times 2. There you are. m2 y2 is 1 times 1 plus m3 y3 is 1 times 0 divided by 3 plus 1 plus 1, and that is 1.4. So where is the location of their center of mass? Their center of mass is at x equal to 2, y equal to 1.4. X equal to 2, y equal to 1.4 is somewhere here. And tell me, we have been told that there is a force F equal to 12 Newton applied to the 3 kilogram ball. There is no force on B or C. The 3 kilogram ball at A is a force of 12 Newton is acting on that. Tell me, what is the net force at the center of mass? Well, the net force at the center of mass is the sum of the forces acting at the different objects of the system. So that will be 12 Newton I plus 0 plus 0. The net force acting on the system is 12 Newton I. Therefore, the acceleration of the system is the net force divided by the total mass. And that is 12 Newton I divided by 5 kilogram, and that is 2.4 meter per second squared is the acceleration of the center of mass. Is that right? I hope that is clear enough, that you have a clear understanding of the center of mass, how to locate the center of mass, how to find the velocity of the center of mass, and how to apply the laws of motion to the motion of the center of mass of a system of objects. I will stop this part of the lesson here and continue with the second part a little later.